Greetings of the day. Myself, Dr. Imran Kuttagola, Assistant Professor in MITS Deemed to be University. It's great privilege to give a e-content on smart construction, where I'm going to discuss about BIM and artificial intelligence in modern construction practices. So the world is becoming sophisticated with constructions, where constructions are required for the growing population, and we have to construct constructions or roofs over heads of the millions of peoples. So the traditional orthodox methods are nowhere relevant or sufficient to meet the demands of this modern population. So we have to adopt the advanced construction technologies such as BIM and artificial intelligence to meet the huge construction requirements of the population, so that we can manage time, cost and resources effectively. So for this, I'm aiming here to give a small presentation on this smart constructions. We'll move forward with the next slide. So first I will start with why civil engineering. So civil engineering, as you know, it is evolved many centuries ago, before any engineering has evolved. So the civil engineering is the backbone of the infrastructure development. So the civil engineers especially targets mainly roads, bridges and very advanced buildings, dams and other metro cities or metros. So the civil engineers will shape the cities, so they will develop economies, they will build the sustainable futures. The word sustainable here refers to a very important and relevant to this presentation, because the resources are becoming very less. So the advanced technologies has to be implemented to build the sustainable infrastructures. So sustainable infrastructure is nothing but green infrastructures, where we have to use the effective methods to develop the infrastructure. So I slowly will go into the presentation. We'll talk about many things about sustainable facilities and sustainable infrastructures required for the advanced construction technologies. So next, civil engineering. Let's see what's the past, present and future of civil engineering. So the ancient wonders, not even the, we can mention a lot. So there are huge ancient wonders which have been constructed even without technology. So there, that is really a marvelous in the civil engineering. So we have built without any modern technology the highest temples in this world, the highest pyramids, so you can say the longest Great Wall of China. So whatever, there are large ancient monuments which have been constructed with modern technology. So but why we are not cope up with this present technology? So in this advanced world, why we can't able to create such wonders? Definitely we can create. So for that we have to adopt some sustainable technologies which will be taken from our ancient technology. So we will in present, what is the going on in civil engineering? So we are focusing mainly on smart cities. So cities have been constructed from many centuries, but smart cities are required for the growing population and present industry requirements. So we are building metros, skyscrapers. So what will be the future of this civil engineering? So we'll build green buildings. So green buildings, again I will talk about sustainable, and where we can adapt the waste resources. Especially I can say that we have to construct the buildings from waste, we have to convert the waste to wealth to develop these infrastructures. We can call those buildings as green buildings. There are n number of methods to develop these green buildings. And especially I can talk about AI based construction, sustainable materials. So artificial intelligence, I can say it is ruling the world like anything. It came out of a bottle like a genie. So it will give all the wishes whichever you want, but we have to learn how to use that AI in construction materials. In our coming slides we will see the importance of AI, importance of BIM, importance of advanced technologies to build these green buildings or sustainable infrastructures. So let's see a small recap of famous civil engineering wonders of this world, so that we'll get a motivation to listen further the presentation ahead. So civil engineers makes the impossible things possible. So there are great civil engineers in this world who have built a marvelous structures and made impossible world a possible in present civil engineering constructions. So we'll see Burj Khalifa. So we all know, we have gone through the n number of videos in the internet also, like Burj Khalifa has emerged as a tallest structure in this world. It is designed by Skidmore, Owings and Merrill. So it has been inspired by the geometry of the regional desert plant. So we can see the triangular geometry, which is the geometry of the famous plant in desert available over there, which is adapting and surviving in that harsh climates, so that we can adapt that technology even in this environment in desert areas. In the loose soils, they have built the highest monument ever. So which can be possible only if we adopt the nature technology from the nature around us. So this is a great inspiration how we can adapt the nature's technology to build such skyscrapers. I can say next one is Three Gorges Dam, China. It is a marvelous engineering wonder. So you can it gave us so much impact that it has changed the revolution speed of the Earth's revolution. So this is the largest. It has the largest capacity of hydroelectric power station, because a huge reservoir has been constructed. A large amount of water is available, which can be stored in the reservoirs to produce this water power into a hydroelectric power. So in this massive construction, due to this huge amount of reservoir storage, it has changed the earth's rotation by 0.06 microseconds. Let's imagine, it's not a small uh, number. 0.06 microseconds, a small construction is changing the huge radius of this earth, huge wonder in this universe, our earth. It is making the speed of this earth's revolution reducing by 0.06. That much impact it has been created on the earth. So it is designed by again the famous architect Zheng Shoren. So this is a Three Gorges Dam in China. We will see the marvelous of our India recently, Chenab Railway Bridge. It is a proud to be for Indians to construct such a marvelous bridge. It has been constructed on the Chenab River. It is created a record that it has a height of more than an Eiffel Tower. So it has been constructed between two mountains. So it is a marvelous, like huge geotechnical engineers and railway engineers, everyone has involved in this to create such a marvelous construction in the hilly areas. So you can imagine there are no resources, how difficult it will be to travel over there. So but they have created and they have opened this bridge for transportation. So is a world's highest railway arch bridge, we can say. We are proud to be an Indian. So incredible engineer behind this world's highest railway arch bridge. So the Chenab railway bridge, it is constructed in the Chenab Jammu and Kashmir area. So next, these are there are many wonders which we can talk. So but let's constrain to this topic presentation. Now I will move forward with BIM plus AI in construction smart infrastructure. So this BIM has been using from many decades, and AI has been emerged as an a genie out of the bottle. What, let's imagine if we mix this BIM and AI, how many wonders you can create. Even without this, we are creating huge wonders, like from ancient history to the modern construction world. We have created many constructions, many marvelous structures. What if, imagine, just if we club this beam and we can adopt this AI in construction, we can create a smart infrastructure. The word smart here, it refers to a like we are going to create the huge wonders in the coming years by using this technology. You can remember, at the lowest cost. Cost is very important in this growing economies. So population is growing like anything, so economies are also growing. We need huge resources, huge budget to construct many wonders in this world. But we have to optimize all the cost, which will be possible only if we adopt BIM and artificial intelligence. So let's see in this coming presentations what is the advantage of BIM and what are the different AI technologies required to make this happen. The future civil engineer will not only build structures but will also manage intelligent digital infrastructure. The word digital infrastructure has been clubbing the digital world with construction world infrastructure. With digital technologies we can adapt like BIM and AI, so we can create not only the structures but we can manage and we can create an intelligent digital infrastructures by using these technologies. So I will see start with a few slides with fundamentals of a building, because we are civil engineers, we should not forget our fundamentals. We'll focus on the fundamentals. So every structure, whatever the construction on this world, it will have two components. One is superstructure, one is substructure. I'm not going to discuss much about these parts. So superstructure is everything that is obviously laying above the ground, and substructure is a part of the building that lies below the ground. So we have to balance both superstructure and substructure to create these wonders. We'll see, this is a small presentation I have collected from the BIM Revit architecture user interface. So I will explain all these components in the coming presentations. So this here you can see the substructure foundation. It is a part of a substructure where huge reinforcement formwork is being making ready for the construction of this substructure. So we have different types of foundations, as you know. I'm not going to in detail again. So my target and my goal is of this presentation is to focus more on BIM and artificial intelligence. At the same time, I'm revising all these fundamentals if for the basic understanding of the advanced structures. So shallow foundations, you know what are the different types of shallow foundations: isolated foundations, individual footings, combined strip and draft foundations, and many others. And deep foundations, for example, we can say pile and drill shafts, and some others are also there. Based on the requirement of the structure or the ground condition, will adopt different types of foundations. Then coming to the superstructure generally consists of columns, beams, floor slabs, doors, windows, finishes, whatnot, many other components which you can see with your naked eyes. So here is a small sample example of this superstructure, where you can observe different types of steel columns, beams, floor slabs, here doors, windows we can include in this. Again, this slide has been taken from the BIM Revit Architect in a user interface. So next, coming to the finishes. Finishes is the most important component of this structure. It will resist impact, water, frost, corrosion, abrasion, and it will give a decorative function of the component. So these are different architectural buildings which we can construct using digital technologies. Here I have referred some of the examples, some of the models created by using BIM technologies. So these are the, see, you can create textures, colors, materials, plasters, and even we can paint by using different BIM technologies. So these are the many some samples taken again from the user interface Revit architecture. So next, coming to the building information modeling, which is otherwise called as BIM. So BIM is nothing but here we can study whole the functioning of the building even prior to the construction starts. So even before the construction start, we can visualize our structure, we can redesign our structure, we can reallocate or rearrange the components of the structure. Say for suppose we have nowadays we have a traditional style, like we want to create or insert one AC, indoor AC or split AC in our house. So all the construction completed, after arranging the beds, everything, once if we want to fix the air conditioner, what we have to do, we have to make a like a hole for the outlet pipes and circulation, everything. But what if we want to change again the position of the air conditioning? So we have to again demolish all the construction layout in the wall, and again we have to make some other location and some other reconstruction works we have to do. So what if we see, for suppose by using building information modelings, and or if we create a digital structure of your building even before construction, we can go through the walkthrough, we can make a walkthrough of our structure of our house, we can walk inside, and we can just before the construction starts or even before construction occupies, we can select where our functions or components of the building has to be allocated, has to be fixed. We can first initially fix the AC location point, everything, and then if we start construction, after finalizing everything even before construction, there will be a minimum, or I can say a negligible or no wastage of the manpower or resources. So that is a huge advantage of building information modeling. Not only this, there are many other BIM softwares where we can adapt in the constructions, multi-story constructions. We can optimize the resources by using these technologies. What is a BIM? So BIM is nothing but building information modeling. The name itself suggests the buildings information can be modeled even before construction. It carries whole information of the building. So in form of digital. So we can digitalize the information of the building, like mechanical components, electrical components, plumbing components, structural drawings, structural steel reinforcement, structural components of the building, whatever. We will digitalize whole information of the building, and we can modify at any point of time, and while during construction or before construction, even after construction also, for maintenance works, we can use this digital model. Say for suppose a structure has been constructed, we want to do some maintenance works, we can't do trial and errors in the real construction, right? So it will gives us a lot of wastage. So what we have to do, we have to go and work with this digital model. Again, what we can do here, by using this digital model, we can do the modification works required in your structure. Just check everything is okay, clear, then again go for the rehabilitation or whatever the remodification of your structure. This BIM building information model will help us to modify the components of the structure of a build or of a structure. So it is a digital process to create and manage the information of a building throughout its life cycle, not only during construction, not only before construction, even after construction, till its life exists. That digital model will be stored in your laptops or desktops, but you have to secure that digital model. So any changes you required in its complete life cycle, say for suppose this structure, this hall has to be changed to some other form in the future, maybe after 40 years, 50 years, this place can be occupied with different function. So what we have to do, our building information model of this hall will be ready with in the form of soft copy. So we can edit that, we can remodify whatever the functions required in this building. Again you start constructing or modifying the structure. So it will help for your complete life cycle of a structure. This information will helps you to balance the resources and cost. You can see here there are different process or steps in this building information modeling. So especially the definition here will understand the design information. So the design of this structure will be stored here in the form of digital information, and again the structural planning can be stored here, and the cost estimation also we can do using this building information modeling. So even the structural details can also be stored. Reinforcement details and layouts can be stored in the form of BIM. So even again sorry, cost estimation has been repeated. So maintenance of the data, for maintenance works we can use this building information model of your structure, so that you can completely play with your structure at any point of time in its life cycle. So BIM is nothing but a 3D model plus information plus collaboration, I can say. So we will stop our presentation here at this point. In coming next presentation, I will explain the few details of your BIM models and different user interfaces used in the Revit architecture. Thank you one and all. Signing off. Bye bye.